Hello, everybody. It's been an interesting week on the bulletin board. The topic has been the normal distribution, and as Jennifer said recently, no, I was not really looking for you to create perfect-looking bell curves. What I wanted us to do was to look at our data and perhaps create frequency distributions and evaluate whether our data set was normal or not. That was maybe it wasn't said right, and I'm going to have to rewrite that post. Instructors don't write those posts. They come to us, but that one is bad enough. I'm going to modify it. Anyway, okay, well, I'm going to do an example here. Jules was having some difficulty, and she posted the data that you see here, and I'm going to use her data and do what I would have liked to see us done. It's quite a bit of work, but whatever. Here we go. Okay, I'm going to grab this data, and if I'm lucky, I'm going to be able to drop it in Excel. So I'm going to do a Control-C to copy it, and now I'm going to jump over to Excel, and I'm just going to paste it here. Let's see, Control-V. I got lucky it worked. Sometimes it doesn't. Sometimes you have to do paste special and choose text. I'm not sure this is going to work. Let's see. Are these numbers or are they text? We'll find out. Okay. So first of all, I don't like the way those rows disappear. That's just me. That's because of the fill they put in there. So I'm going to say no fill. Now I got my lines back. Okay. What do we know about a normal distribution? Well, one thing we know is that the mean is equal to the mode, which is equal to the median. Yes, it's perfectly symmetrical. We also know about those percentages, that the mean plus or minus 1 standard deviation gets us 68% of the values. And let's see, there's also mean plus or minus 2 standard deviation gets us 95.5, is that right? Percent of the values. And SD, sample standard deviation plus or minus 3 standard deviations. Sorry, that's just Dad calling, he can wait. Gets us 99.7% of the values under the curve. Okay, so we know those things define a normal distribution. Let's test our data set and see if it meets those criteria. Now, why are we concerned about this normal distribution stuff? It is because in much of statistics, some of what we're going to do, and many of the advanced tests and conclusions that are reached are based on the assumption that the data comes from a normal distribution. And if it doesn't, boy, the game's off. You can't trust those statistics that you're calculating. So it is important to be able to judge a distribution. So, okay, first thing I want to do, and you'll see why later, I want to sort these data. So I'm going to select the whole group, and let's see, Data tab, we have a sort button. And the sort dialog box says, what do you want to sort by? And I want to sort by column B. Smallest to largest. And sure enough, there it did it. Now my data are in order smallest to largest. I don't care that they I don't care that the months are out of order. I'm just trying to clean things up here. I'm persnickety about stuff like that. Okay, so now we need to calculate some stats. First of all, let's check out that mean equals mode equals median thing. So I want to calculate mean, mode, and median. Well, we know how to do that. We're pretty good at that by now. At least we should be. The mean. We have an average function we can use. There we go. The mode. Well, as I look through this data, I can tell you something. There's no mode. Why? In order to be the mode, that's the value that appears most often, and these values, every single one is unique. Well, I'm going to prove that to myself. I don't see any though. Let's see, mode single tells me that'll work. Whoopsie. Mode single tab. Data range and enter, and sure enough, I get an error and it says value not available, which means there's no mode. So we're going to get rid of mode, and we're going to calculate median instead. Equals median. There we go. All right, right away, have we violated the mean versus equals mode equals median? Well, look at our mean and median. Are they the same? No, they're not. So we've already violated. Maybe we haven't violated too badly. Maybe it's still a normal distribution. Just glancing at it, it looks pretty normal to me. But we don't know that yet. Let's do some more work. Okay, let's calculate standard deviation. We're going to sample standard deviation. Oh, I'm popular today, and now number one son's calling. I'm going to let him wait as well. I want to finish this video. Okay, so there's standard deviation. Okay, let's see. Okay, we know standard STDEV will give us standard deviation. Enter, and there's my standard deviation. All right, now I want, let's see, I want to evaluate these mean plus or minus 1, plus or minus 2, and plus or minus 3 standard deviations. So let's see, I'm going to say mean plus or minus plus, so I've been writing it 1 SD, and I'll copy that down a couple cells, and I'll change this to 2, and I'll change this one to a 3, and I'll make these columns a little wider, not that wide. Okay, so now let's see. In this spot, I'm going to calculate equals the mean minus the standard deviation. Oh, okay. There's mean minus standard deviation. Over here, I'm going to put the mean plus standard deviation. And there we go. The mean plus or minus 1 standard deviation is a range from 1217 up to 1836. Simple enough. Let's do the mean plus or minus 2. Well, let's see. I'd like to copy these, but it's not going to do it for me unless I make them absolute cell references. How do I do that? I hit F4 for both those values. Likewise, I'm going to hit F4 for both those. And now when I copy them, it's going to copy the same exact equation. Sure enough, it's not what I want yet. But let's look at this first one. All we have to change is we want this one to be multiplied, the standard deviation to be multiplied by 2. So I'll say 2 times. And this one, we want the standard deviation to be multiplied by 2 times. And you can see the range is growing. The first one, 1218 to 1836. The second one, plus or minus 2 standard deviations, it pushes everything out. It goes from 908 to 2136. And now, of course, for the third one, I'm simply going to say 3 times the standard deviation and 3 times the standard deviation. Okay, we're going to come back to these data in 1 minute, but first of all, I want to make a frequency distribution because it's real nice to have a quick picture of your data to see if perhaps visually we can detect whether it is a normal distribution. Now, what we need to do that is to create, I'm going to use our histogram function in our, let's see, data analysis. So we need bin ranges. So I am going to, right over here, I'm going to type bin. What's bin? Container. Yeah, we've been through that one. Let's see. Bins, I'm going from about 1100 up to 1400. I think I'm going to try 100 at a time. So 100. Well, there's not that many values. Well, let's see. How many boxes, how many bins will this give me? I think I'm going to go back to 1200. So I'm going to type 1200 here. This is called autofill. If you give it, show it what, how you want to be adding each time going down, you highlight the 2 and then use that little corner guy, and he continues your term, your addition. Okay, so I'm going from 1000, which will certainly cover this bottom end. I want to go up to about 2400 to be sure I cover that one. So I'll delete those 2. There's my bin range. And now, you can't see it, I clicked data analysis. There's our histogram function. It wants to know where my input range is. It's not there, so I will say my data is right here. And let's see, my bin range is not there, it's over here. Okay, I'm going to put this in a new worksheet. I want a chart. I say OK, and wow, there's our data distribution. Now wait, let's jump back. What was our mean? Our mean is 1527. Okay, just double checking. 1527 is right about in the middle here. Does this look like a normal distribution? Well, it's sort of bell-shaped, isn't it? It looks like it might be skewed, though. Skewed to the right end here. Yeah, we're kind of short of values on this end, and we have some extras here. Maybe it's not too far from a normal distribution, though. I'm thinking it's pretty good. Well, that's my guess. Okay, so let's go back now and let's do this test. How many values fall within these ranges? How many values fall within, let's see, the mean plus 1 standard deviation, the mean plus 2 standard deviations, fine, whatever, and the mean plus 3 standard deviations. Oopsie. Highlight those. Double click. Interesting. Whatever. We'll leave it like that. Okay. So what I need to do is to think about my data. Mean plus 1 standard deviation covers the values from 1218 to 1836. Well, let's see where those breaks are. Again, I'm going to just highlight my data so it's clear from this stuff at the bottom. Whoops, I already missed one. I'm going to make these guys red. Okay, so where does 1218 and 1836 fall in this ordered arrangement? Well, let's see, 1218 is going to, let's see, 1158 is too low, but 1340 is not. So I'm just going to put stars there. There we go. And let's see, how about at the high end? 1836 will cover 14, 16, 18. It won't cover the 1900, so we're going to have a set of stars here. Okay, so all of these values in the middle, including the stars, are covered by this range. And what percent of values is it? Well, let's see. It's 1, 2, 3, 4, 5, 6, 7, 8 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 8/12. Let's calculate that percentage. 8/12. Whoa! We're supposed to have 68% if it's a normal distribution. And what do we have? Well, let's put it in percent. Whoopsie. Put all three of those in percent. Percent button, where'd you go? There you are. What's this 2 doing down here? Don't know. 67. That's real close to 68%. That's showing some strong evidence that this is a normal distribution. All right, let's try the mean plus 2 standard deviations. Well, let's see. We got to go from 908 to 2146. Oh boy, 908 covers the very lowest value. And 2146, well, that's beyond the largest value. So what have we learned? We didn't cover 95.5% of the values. We covered 100% of the values. How about mean plus 3 standard deviations? Well, I can already tell you that if mean plus 2 covered 100%, mean plus 3 standard deviations is also going to cover 100%. 599, yes, well below 1124, and 2455, well above 2135. Again, we have 100%. Okay, so what does this show us? Well, let's see. We were looking for 68%, 95.5, and 97.7. Well, that's real close to 97.7, and perhaps our mean plus or minus 2 standard deviations is a little bit off. But hey, it's not far, and that 67 is real close. Let's go back. Look at our histogram. 1500 was our mean. Yeah, pretty bell-shaped, isn't it? I would say so. So there we have it. Joules 2.0 is complete. This is kind of how I'd like you to analyze your data, or how I wish you did. It was quite a bit of work, but this is the full-fledged everything I could ever possibly want. Again, you guys were doing some innovative and creative curve creation, creating a normal curve based on some stats, the means and standard deviations that you calculated. But this is what I really wanted you to do, to look at your data set and evaluate whether or not it was normal. Again, we do that because many parts of statistics rely on a normal distribution. It's an assumption that's made, and before you can calculate any statistics or perform any advanced statistical tests, you have to have a normal distribution. Are there ways around it? Oh, there certainly are. Those statistics people, they will do magic to your data, and they will transform it and create a normal distribution from it, at which point they can do statistics. But that's well beyond our course. Whew, 18 minutes. I didn't think it would take that long. I'm going to post this so everyone can see it. See you guys.